Question 19a says, explain why natural rain has a pH of around 5.6. Give a chemical equation to support your answer. So 5.6 is acidic, but it's not especially a strong acid. It's a fairly weak acid. So the reason why rain is always somewhat acidic is because there's CO2 in the air, and rain will dissolve CO2. So if I have H2O plus CO2, I'm going to end up with some H2CO3, which is a weak acid. And again, there's not going to be a lot of it. It's going to be somewhat soluble in the water. Part B said acid rain may be 50 times more acidic than natural rain. One of the major acids present in acid rain originates mainly from burning coal. State the name of the acid and give equations to show how it is formed. So the acid from coal is sulfur in origin, so that would be sulfuric acid would be the name. And one way it can originate is your sulfur combines with oxygen to form the SO2. And then SO2 can combine with oxygen in the air. So this happens when you're burning the coal, the sulfur and the oxygen form SO2. But SO2 in the air then forms SO3. And then SO3 combines with water. And that's when we have the strong acid H2SO4. The SO2 can also combine with water to form H2SO3, but that isn't as damaging because it's not as strong an acid as sulfuric acid is. Part C, the second major acid responsible for acid rain, originates mainly from internal combustion engines. State the name of this acid and state two different ways in which its production can be reduced. So I'm going to go ahead and clear some space here, and we'll take a look at that. So part D, the name of the acid is nitric acid. And I don't have to write any equations here. I have to state two different ways its production can be reduced. Catalytic converters is one way. And that's a common way on cars in the United States. And another one is recirculation of exhaust gases. Can also use what are called lean engines. There's a few ways given in the book, but that's two of the ways. Part D, acid rain has caused considerable damage to buildings and statues made of marble, CaCO3. Write an equation to represent the reaction of acid rain with marble. And so if I look at CaCO3 being, I guess this was actually C here. I've got my lettering messed up, so let me create some space here. This is C. This is going to be D here. So CaCO3 with either HNO3 or H2SO4, what's going to happen is you're going to have a replacement reaction, and you're going to end up with H2O and CO2 from the H2 and the CO3 combining, and then you're going to be left with calcium sulfate instead. And the problem is that calcium sulfate is aqueous and will wash away, whereas calcium carbonate is not particularly soluble in water. In fact, I can list it as a solid there. So calcium carbonate, marble, rain, hits marble or limestone, there's very little effect on it, but calcium sulfate is highly soluble in water. So that's the problem, is you're changing the calcium carbonate to calcium sulfate, which is a far more soluble mineral or ionic compound, I guess I should say. Part E says state three consequences of acid rain, and there's a bunch of them, so I'm not going to write these down. I'm just going to list them off instead. Basically, if you think about different aspects in your life, it affects buildings and statues by washing away the calcium sulfate that it forms. It corrodes metals. It can affect plant life by leaching necessary ions out or releasing aluminum ions, which damages roots. It can kill off aquatic life in lakes and rivers. It can harm fish with the aluminum. And finally, with humans, it causes respiratory issues such as bronchitis, asthma, emphysema, and irritation of the eyes. So part F, suggest a method of controlling acid rain not involving a chemical reaction for reducing sulfur dioxide emissions from power stations. So a common one is to use an alternative fuel. We'll go ahead and write these down. So F, use other fuels. Another option is to use low sulfur content coal. And a third one is you can actually wash the coal beforehand. You can crush and wash it, and that will help before burning it. So there are some options to lower these emissions and cut down on the amount of acid rain out there. Question number 20 is also multi-part. Question 20 asks, identify the pollutant which contributes to acid rain. It's mostly the SO2, but it certainly can be NO as well. So SO2 is the big one, and NO also can contribute to it because you can make H2SO4 and HNO3 both. Identify the pollutant which comes mainly from power stations. That would be the SO2. The presence of one of these pollutants makes the ill effects of the others worse. Identify the pollutant and explain why it has this effect. In the case of letter C, they're talking about the particulates because the particulates act as a catalyst. And as you know, a catalyst speeds up the reaction rate, so it will definitely make the production of the secondary pollutants like the HNO3 happen more quickly than if there weren't particulates available in the air. D says emissions of one of these pollutants has been controlled by reaction with calcium oxide. That's the sulfur dioxide, and the equation for that, if you take calcium oxide and expose it to SO2, you can form CaSO3, which is a gas which then can be collected. Identify the pollutants that come primarily from motor vehicles, and that would be the NO. And it says, describe the basis for their production. You have to have high temps before this occurs, but car engines do have high temps. But the high temps is what allows the nitrogen and oxygen in the air to combine. Because certainly under normal conditions, we don't have trouble with the nitrogen and oxygen in the air combining. Question 21, describe the difference between dry acid deposition and wet acid deposition. And it's, the obvious difference is one is dry and one is wet, but dry acid deposition typically occurs close to the source of emission. It's kind of like, dust or soot. If you're near a fire and you get soot, you notice it around the area. That's kind of what dry acid deposition is like. Wet acid deposition gets carried up to long distances away from the source because it's carried with the moisture in the air, and it can remain with that moisture until the precipitation falls. So it can end up over a much larger area and much further from the original source. B says, explain the physical and chemical processes involved in the development of wet acid deposition. Well, it's formed in the air from the sulfur dioxide and the nitrogen oxide, which are emitted by the power stations and the motor vehicles, and then it ends up combining with oxygen and water in the air and then getting carried by the prevailing winds. So to just summarize some of the things here, dry is deposited near the source, wet combines with water and can travel far and wide from the source. So then the physical processes here are mostly the winds carrying things far and wide from where they occur. And then the chemical is that you have the NO and SO2 emissions, which combine with oxygen and then later with water to form the strong acids, which do most of the damage. Number 22 says, identify the free radical involved in the formation of sulfuric acid and nitric acid in acid rain and explain how it is formed. This is really beyond what you really, I mean, I can't imagine this is going to show up on the test, but for the intellectually curious, the free radical is OH with an unpaired electron. So instead of having that minus charge on it, it hasn't picked up the other electron. So instead of being OH minus, it's OH, and we just put this dot there to show it's unpaired. And the whole mechanism is shown on the key, or you can find it by reading the book. But again, we are going to get to free radicals a little bit later when we do some organic chemistry. For now, I wouldn't be too concerned about it. Question 8 and 9 are more likely what you'll see on the IB test. You're more likely to see multiple choice or paper 1 questions regarding the acid rain and the environmental effects of it. So which of these reduces the production of acid rain? Removing SO2 from power station emissions? Absolutely, that would cut down on it. Neutralizing acidified lakes with lime, that helps reduce the effects of it, but it doesn't reduce the production, and that's the key here. So this one isn't going to reduce it. And switching to renewable energy sources, that would help reduce the production as well. So 1 and 3 will reduce the production, which would be letter B. Number 2 helps, but it doesn't reduce the production. It deals with it after the fact. Number 9, which of the following occurs as a result of acid deposition? Ca2 plus ions are washed out of the soil. Yes, different ions can be leached out of the soil. Thermal expansion of oceans, that's part of the warming of the earth, but that's not from acid deposition. That one can't be blamed on acid rain, even though it's occurring. And fish are killed due to high levels of aluminum. That also can happen. So again, B, 1 and 3 are the ones that can be blamed on acid deposition. And finally, number 14, define the term acid and base according to Bronsted-Lowry. Distinguish between a weak base and a strong base. State one example of a weak base. So an acid is an H plus donor. A base is an H plus acceptor. That's the simplest definition. Distinguish between a weak base and a strong base. I guess this is all part of 8. Weak only partially dissociates in water or partially ionizes in water, whereas strong is considered to completely ionize in water. And state one example of a weak base. When you're looking for a weak base, go to your organic acids and bases, go to your data booklet, and you should be able to find one. The easiest one that I remember is NH3, because I know it will gain a hydrogen to become NH4. Looking in your data booklet, you could easily find something like CH3, CH2, NH2. But the NH2 is the key there, that's going to be, or NH3, that it's likely going to be a weak base. And then part B, weak acids in the environment may cause damage. Identify a weak acid in the environment and outline one of its effects. So 3 common weak acids in the environment are HNO2, which forms from the NO emissions, but it's not as damaging as the HNO3. So then also H2SO3 can form, but isn't as damaging as H2SO4. And then, of course, carbonic acid, H2CO3, forms from the CO2 combining. And they all kind of do the same thing, but to a much lesser degree than what the strong acids do. They can corrode marble and limestone. They can leach the soil. They can be harmful to plants and or aquatic life in our lakes and rivers.